Again, we use a partial fractions decomposition to solve this antiderivative. The first part is done for us. The denominator is already factored. That's great. This will not factor any further. It's not x plus 1, x minus 1, because we get a negative in the middle. There's no way to factor what's left here. So we just need to, at this point, go right to our next step and write out the decomposition. Remember that this will be a over x plus 1. And remember from some previous homework problems that when we have a quadratic in the denominator, we need to allow for a generic linear term in the numerator. So this is not just b. This is bx plus c. That's required to allow for any combination to make this numerator. If I just had a constant here, then I just have a and b, just two variables, and there's no way to possibly make three different variables as the coefficients of x squared, x, and the constant. So we have three possible variables in the numerator, so we'll need three variables over here in our decomposition. At this point, we clear out the denominator just as before. That is the same process. And then we choose our favorite values of x. There's only going to be one really good value of x here, negative 1, because nothing will make this 0. But we'll still let x equal negative 1. If we do that, that makes 4 times 1, which is 4, minus 1 is 3, plus 5 is 8. When I plug negative 1 in, I get 1, so that's 2a. And this goes away. So that's just 2a, which tells me that a is equal to 4. Again, there's no second choice here that makes sense, so we just have to pick anything. When I have the option, I like to pick 0, because that does make for some nice stuff. Lots of stuff goes away. We'll get 5, this is 0, this is 0, this is 5. This is 0, so that's just a, but a is 4. Right, so a here is 4 times 0 plus 1 is 1, plus b times 0, so that's gone. So that just leaves me with c times 0 plus 1, which is 1. So 5 is 4 plus c, so that tells me that 1 is equal to c. We still need to figure out what b is. There's one last requirement. We've got to plug in one other number. Again, any number at all will work. So we're just going to plug x equal to negative 1 in. If I plug x equal to negative 1 in, I get 4. Minus 1 is 3. Sorry, we don't want to plug x equal to negative 1. That we already chose that. Let's plug x equal to positive 1. If we put x equal to positive 1 in, I get 4 plus 1, which is 5, plus 5 is 10. A is 4. Plugging 1 in for x makes a 2 here. Plus b, which we don't know, times x, which is 1, plus c, which we've already figured out is 1, and x is 1, so that makes a 2 here. So that's 10 is equal to 8 plus 2b plus 2. By distributing the 2 in, 10 is 10 plus 2b. Subtract that out, we get 2b is 0, so that b is 0. Now we've got A, B, and C. And we just plug them in and find our antiderivatives. This will be 4 over x plus 1. B is 0, which does make our life nice. C is 1. That's x squared plus 1. And we're looking to find the antiderivatives. This one we've seen a bunch. Linear factor in the denominator makes ln. So that's ln of absolute value of x plus 1. All multiplied by the constant 4 out front. And this one we haven't seen for partial fractions, but we have seen it before. This is 1 over x squared plus 1 is, we could go through a whole tangent substitution, or just recall that since everything is 1 here, this is tan inverse. This is just tan inverse of x plus c. And that's our answer.